Okay, so here's our word problem. We have an airplane flying with an airspeed of 310 knots on a heading of 50 degrees. Let's just start with that and we will build on sentence by sentence. So I'm going to go ahead and draw my axes out. I see that it's going 50 degrees, so I'm just going to go ahead and just draw north and south on that right there. So it's going at 310 knots at a heading of 50 degrees. So it's going to be a little bigger than halfway from the north. We'll call that 310. And that's 50. Okay. If a 78 knot wind is blowing from a true heading of 125 degrees, determine the speed and direction. So once we get to that ending of that first piece, we're going to redraw our axes, and it's a true heading, which means that that's 0. So we're looking at 125 for 78 knots there. So this outer piece is 125. 125 degrees, sorry, and this is 78 knots. Okay, we want to see where they end up relative to the ground, which is going to be from here to there. Let me extend my line. Give me a second. Delete. I'll just hand do it. Obviously, it's not going to be perfect. It's on my iPad. Okay, we need to find that resultant. So, in order to find the resultant, let me see if I can zoom in this piece. We need to see what the angle, hold on, some red marking got all over my triangle. The angle of our inner piece on our triangle, which let me mark that in yellow. We need to know this angle in order to use the law of cosines to find that distance that g is, or how many knots the vector g is. That's our resultant. So what we need to do is we need to see what will be parallel with that. Now, looking at the parallelogram method, if, say, I just get rid of this black line, and if I drew this out using the parallelogram method, that red line, let's see. I'm just trying to make it the most accurate to what I've got. So this line right here is parallel to that piece. So what we want to do is we want to find the measure of this, which is 125, that whole measure parallel to that, minus the 50, because this piece right here we'll call alpha. That is the same as the one on the inside. So how do we find that? Well, if we have 125 degrees and we're taking out that portion of 50 to find what's left, that's going to give us 75, and that is our alpha measure, 75 degrees. Now, if I have a side angle side and I need to find a missing side, what can I use? I can use the law of cosines. So that means I've got g squared, because that's what I'm looking for, equals one of my sides. So 310 squared plus 78 squared minus 2 times 310 times 78 cosine 75 degrees. Hopefully it's coming back to you guys. Once you go through and solve that, you should get g, after you square root and everything, g to be around 299.4, which what we're using is knots. So it's saying that the ground speed of the plane is 299.4 knots. Now we don't know the heading, which is this, let's see, I'll use green, this piece within our triangle. But we now know two sides, and we can go ahead and use the law of sines to find that missing angle. So the pairing we do know is sine 75 over 299.4. equals sine, I'll just say beta. That's what we'll call that, angle beta. You guys can actually call it theta. I don't have anything labeled that. Sine beta over what's across from it, 78. 78 sine 75 degrees over 299.4 equals sine B. Then you have to take the inverse sine to make all that go away. So sine to the -1, sine to the -1. B is approximately 14.6 degrees. And that is just the piece in the triangle. So we have one last piece because we need to find the direction from the beginning. So our true bearing, or our heading, I should say, not true, but just the heading. So we started with 50, and then we subtracted this 14.6 to find the total piece where that blue line is. I know that's really hard to read. Okay, so that is 50 minus 14.6, which is 35.4 degrees. So we traveled, or the airplane, not we, I wish we were on the airplane, but it traveled 299.4 knots at a 35.4 degree heading because of the wind and the speed. All right, I know that one's long. It brings in some of your guys's plane and line theorems, so you're gonna have to think back into that. But go ahead, work on it. Let me know if you need anything else. And yeah, contact me if you need anything.